Hello viewers, and welcome to the lesson. In this lesson we shall go through Form 2 Mathematics Revision. The paper that you're going to solve is New Dawn Series 2025. I have already uploaded section 1 of the paper. You can check it in the recent uploads, it is there. And always remember to go to the description of the video, check the link to download the question paper so that you can have a look at the questions as we continue to solve. So I'll go through step-by-step solutions to all the section 2 questions in this paper, and I hope these questions are going to be significant as you continue to revise for your final examinations. Let's go to the question paper. 50 marks, answer only 5 questions in this section and the spaces provided. So the first question here, that is question 17. Kirui and Karoki formed a trading partnership. Kirui's monthly salary was X shillings, while Karoki's was Y shillings. 1 month, Kirui contributed a 12th of his salary, while Karoki contributed a 10th of his towards the partnership. Their total contribution that month was 9,800. In another month, Kirui contributed an 8th, while Karoki contributed a 6th of their respective salaries. The total contribution for the second month was 15,500. Part A of the question, form 2 simultaneous equations in terms of X and Y. So let's go to the first statement. Kirui's monthly salary is X shillings. So if the first month he contributed a 12th of his salary, so that contribution will therefore be a 12 of X. Then Karoki contributed a 10th of his salary, and his total salary was Y, so that contribution will be a 10th of Y. And this one gave a total of, when the two contributions are added, this one gives 9,800. Before we proceed to the second equation, we can simplify this one to eliminate the denominator to make these equations simpler to work with. We simply get the LCM, the least common multiple of 12 and 10, which is 60, and then multiply both, not actually both, each of these terms by the least common multiple of 12 and 10. So this gives 5x plus, this will be 5y. No, actually this is 5 plus 6, this will be 6. 60 divided by 10, that will be 6y is equals to, multiply these, 9,800 times 60, that gives 588,000. So that is the first equation. We go to the second equation. That one you get it in the other month. So in another month, Kirui contributed an 8th. An 8th of his salary will be an 8th of X. The total salary is X. Then Karoki contributed a 6th of his salary, which is Y, and that one gives a total of 15,500. So we can simplify this one by getting the least common multiple of 8 and 6, which is 24, and then multiply each term by 24. Multiply each term by 24 like that, and this gives 3x plus OY is equals to 15,500 times 24. That gives 372,000. So there we have the second equation. So we have the two equations, the two simultaneous equations are there, that one and that one. Then part B, determine the monthly salary of each partner. So for that one, we are required to simply solve the two simultaneous equations because the month, so simply we are required to solve the two simultaneous equations because the monthly salaries are X and Y. So we take the equations. So the first one here, we have 5x plus 6y is equals to 588,000, and then we have the other one, which is 3x plus 4y is equals to 372,000. So use any suitable method. I'll use elimination. So I will eliminate x. So how do I make x to be uniform? This is 5x, this is 3x. So the least common multiple of 5 and 3, that is 15. So to make them 15, I'll simply multiply the first one by 3, and the second one here, I'll multiply that one by 5. I think that one would be okay, so that I can eliminate x. So the first equation, multiply everything by 3, so you'll get 15x plus 18y is equals to 588,000 times 3. When you multiply that, that will give 1,764,000. Then the second one, 15x plus, this will be 20y, 372,000 times 5. That will give 1,860,000. So there we have the two. We have the two equations now. We can subtract to eliminate x. So x will be eliminated. 15x minus 15x, that is 0. 18y, subtract 20y, that will give negative 2y, is equals to 1,764,000 subtract 1,860,000, that will also give negative 960,000. So divide both sides by -2, you'll get y to be 48,000. So that is Kcse's salary, that is 48,000. Now to get the value of x, you can simply take one of the equations here. I'll take this one. I'll take this equation here, and I will substitute the value of y to be 48,000 to get the value of x. So that is what I'm going to do. So we have 3x plus 4, then y is 48,000, and this gives 372,000, like that. So this will give 3x plus 48 multiplied by 4, that will give 182, is equals to 372,000. So 3x will therefore be given by 372,000 subtract 182,000, that gives 180,000. Divide both sides by 3, you get x to be 60,000. So now this is the monthly salary of Kirui. So this is Kirui, and then this is let me see, forgot the names, Kirui and Karoki. Oh, the first one was Kirui. This is supposed to be x. Let me see, x, Kirui's is x, yeah, Kirui, then Karoki is y. So that is what you're supposed to do. Now from there, I think we've obtained the monthly salaries of each of the partners. They're there. But see, calculate the total contribution of each partner in the 2 months. So in the 2 months, so we can start with the first one, Kirui. So first month he contributed a 12 of x, a 12. Write this one properly. A 12 of x, which will be x, we got x to be 60,000, so this will be 60,000 divided by 12, so that will be a total of 5,000. Yeah, that will be 5,000. Then the second month he contributed an eighth, so an eighth of x, so that will be x is 60,000 divided by 8, that will give 7,500. So now we have the first month 5,000, the second month 7,500. So total, you add the two, 5,000 plus 75, that will give 12,500. So that is for Kirui. So you go for Karaoke. First month. So for the first month, we have the amount there from the equation, a tenth y. So a tenth of y, so it will be, we got y to be 48,000 divided by 10, so this will be 4,800. Then for the second month, the contribution was a sixth y, which will be 48,000 divided by 6, so that will be 8,000. So you have the two contributions for 2 months, so the total, you add 4,800 plus 8,000, and this gives 12,800. So you have the total contribution of each of the partners. So for Kirui, the total will be 12,500. Then for Karaoke, 12,800. That is how you're supposed to solve that question. Question 18. In the figure below, A, B, C, D, and E are points on the circumference of a circle center O, and radius 10 centimeters, and EC is the diameter not drawn to scale. Angle BAE is 118 degrees, and AB is parallel to EC. So the diagram is there. You can see all the angle indicated there and all the vertices labeled there. Part A, calculate the sizes of the following angles. 1, BCE. So you can start with that. Angle BCE. We identify angle BCE. So this is the angle. So for you to solve this question, you need to be well equipped with all the angle properties of a circle. And when you look at this angle BCE, there's a property that you're going to use considering a certain quadrilateral that is here. Quadrilateral ABCE. So look at that quadrilateral ABCE. You can see that all the vertices are lying on the circumference of a circle, and that is referred to as a cyclic quadrilateral. Now, in a cyclic quadrilateral, the opposite angles add up to 180 degrees. This angle that is indicated as 118, and the other one that is angle BCE, the required angle, those angles are opposite to each other. So we can say that angle BAE plus angle BCE should add up to 100 degrees. That is a property. The opposite angles in a cyclic quadrilateral should sum up to 180. So therefore, if this is 118, then automatically the other one will simply need to take 180, subtract 118. And that will give 62 degrees. So this angle here should be 62 degrees. So that is the size of angle BCE. The next one is angle BEC. 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 So for that one, you have to draw a line here from B to E and then to C. So the required angle is this angle that is here. That is the angle that we need, BEC. So for that one, there's another property that we're going to use for us to get that. There is an angle here that we can get. Look at angle CBE. Angle CBE is equals to 90 degrees. What is the reason for that? Angle CBE is 90. That is the angle subtended by the diameter at the circumference. The angle subtended by the diameter at the circumference. So look at this line here, line EC. Line EC is the diameter because you're given that O is the center of the circle. And that means that EC is the one that is subtending angle CBE and the circumference. So that angle is 90. So now having that, you can consider triangle BCE. So triangle BCE, you have 62 degrees and you have 90. That will give a sum of 152. And you know that in this triangle CBE, the sum of angles in a triangle should be 180. So what is remaining? To make 180, you simply take 180, subtract 152, and that will give 28 degrees. So this angle is 28 degrees. So that is BEC, 28 degrees. We got part 3, AEB, AEB, AEB. So AEB is this angle that is here. That is the angle that we need. So how do we get that angle? For us to get that angle, we shall look at the two prior lines here. So there is this line. Look at line AB and line EC. Those lines are parallel. And BE is acting as a transversal. So you know the properties of angles in a transversal. If you have a line that is parallel like that, and then like that, and then you have a transversal, there are these angles. So this angle A is alternate to angle B, and therefore angle A is equals to angle B because they are alternate. So when you look at these two parallel lines, look at AB is parallel to EC, and then you have a transversal here, that is BE is the transversal. So this angle that is here, 28 degrees, is alternate to this angle here. So this is 28 degrees, and also angle ABE is 28 degrees. So ABE is equivalent to BEC. Now having that, now look at this triangle ABE, ABE. So triangle ABE, we have two angles, so we can get the third angle, which is the required angle. So we have 118. So 118 plus 28 plus 28, that will give 146. That will give 146. So the remaining angle, we simply take 180, subtract 146. And that one gives 34. So this will be 34 degrees, the sum of angles in a triangle. So AEB is therefore 34 degrees. We go to the other angle, BDC. Angle BDC So we have angle BDC. So BDC is here. That is the angle that you need to get. Now for that one, we shall use this. Look at this arc or this chord, BC. Look at BC. You look at that arc that is made by BC, or that chord. That arc subtends two angles of the circumference. So from B, you go straight to E, then to C. So look at that angle, 28. The same arc, this arc, or this chord, it can be the chord or the arc. The same chord or the arc subtends another angle at the circumference. So this angle that is here that we require, that is angle BDC. So therefore these two angles are equal. So these also should be 28 degrees. Reason, these are angles subtended by the same arc or chord at the circumference. Looking at these two angles, angle BEC, which is 28, and angle BDC, they are both being subtended at the circumference by this chord. You have chord BC, or this arc that is here. So those two angles are equal. So we have that angle. So angle BDC is 28 degrees. So these should be 28 degrees. So you're through with filling the angles. Now you can go to part B. Calculate the length EB correct to 2 decimal places. EB. So look at EB. So when you look at EB, you notice, as I've indicated here, that there's a right angle triangle that is formed here. So this is a right angle triangle EBC. It is a right angled at B. So I can extract that. Here. So I can extract that. So it is right angled at B. So that is B. And then we have C at the top there. C at the top, and then E. C is here, and then you have E. So we need to get the length EB. So we have the radius given as 10 centimeters. So radius is 10 centimeters. So this one is 10. So EC, the whole length EC will be the diameter. That will be 20 centimeters. So these will be 20 centimeters, not degrees, these 20 centimeters. And then we have the angles. The angle BCE is 62. BCE is 62. It is here, 62. Like that. Actually, with these two only, you can even have the other angle. The other angle here is 28. With, in a right angle triangle, having been given one angle and you have one side, you can use trig ratios. You can use sine, cosine, or tangent to get the remaining side. So I can use sine, for example. Sine of 62 degrees is given by the opposite, because CE is the hypotenuse. Use the trig ratio that has that uses hypotenuse. So you can use either cosine or sine. So sine of 62 is equals to the opposite side, which is BE or EB, divided by let me see here. You can see, so you need to get, there is something. Calculate the length EB. I think EB, or I indicated the wrong one. So EB is the one that is required. So I indicated so the one that is given here is the diameter EC. EC should be 20. Let me correct that. Sorry for that. EC should be 20. So 20 should not be there. 20 should be here. Sorry for that. 20 should be there. So sine of you can also use cosine. Cosine of 28 is equals to adjacent over hypotenuse. So you can also use sine. Sine of 62 is equals to the opposite side, which is BE, divided by the hypotenuse, which is CE, and that one is 20. Or you can use a cosine of 28 degrees is equals to adjacent side, which is EB or BE, divided by 20. Both of these will work. We will try to do that. So BE from here will be given by multiply both sides by 20. So it will be 20 sine of 62 degrees. 20 sine of 62. So that gives 17.66 centimeters. Let's try these, whether we get the same answer for cosine. So EB is equals to 20 cosine of 28 when you multiply both sides by 20. So 20 cosine of 28 degrees. Okay, I'm getting the same thing. So this one still gives 17.66 centimeters. So you can see you're getting the same answer. So you can use either of the two to work out. And that is simply how you're supposed to solve that question. Question 19. 3 trading centers, Banana, that is B, Roca R, and Ngige W, are such that B is on a bearing of 0.30 degrees from W. R is on a bearing of 0.60 degrees from W and 6 kilometers away. B is on a bearing of 300 degrees from R. Part A, using a ruler and a pair of compasses only, a scale of 1 centimeter to represent 0.8 kilometers. Show by construction the relative positions of the 3 centers. So that is what you're supposed to do. So the first one, let me go to the first statement here. WR is on a bearing of 0.60 from W. Because you already have the north there and you have the position of W, so we can be able to locate that. Remember, for true north, this is a line when you're drawing it, although this one is already drawn, you always ensure that these lines, wherever you draw them on the diagram, they are supposed to be parallel. I'll have to emphasize on that. And then when you're measuring true bearing, we measure the angles from the north in a clockwise direction. So for example, we are supposed to measure 0.60. So let me take a pair of compass here. So I'll have to extend this line. Need to be very keen when you're extending this line. You must ensure that me extend it like that, that I'll be able to measure. So from R is on a bearing of 0.60 from W. So from W, these are how you place your you place it like this. And that is okay. So 0.60 from the north in a clockwise direction. So these are where you're supposed to place it, from the north in a clockwise direction. So 0.60, this is the way you're supposed to measure that. So from the north in a clockwise direction, 0.60. So 60 is there. So you draw a straight line here. So from this point, so 60 degrees, I have to extend that. So you can see that is 60. So this angle here, this angle, that is you're supposed to measure the angle. 060 degrees, and the distance is 6 kilometers away. 6 kilometers away. So you need to be very keen with that. 6 kilometers away. So how are you supposed to do that? You're given this scale that 1 centimeter represents 0.8 kilometers. So what about 6 kilometers? 6 kilometers, how many centimeters are you going to measure for that? So you cross multiply, so this will be 6 divided by 0.8, and this will be 6 divided by 0.8, this will be 7.5. So you have to measure 7.5 centimeters. So this is what I'm going to do. You simply take that measurement, 7.5. I'll use my pair of compasses here. It is calibrated. So 7.5. So there it is. So 7.5 is up there. So this is now R. So we've been able to represent that. That is point R. So R is on a bearing of 0.60 from W and 6 kilometers. So 6 kilometers is here, which we've measured. That is the equivalent of 7.5 centimeters. Then B is on a bearing of 300 degrees from R. So we have to measure 300 degrees from R. So what we need to do is to construct a true north at R. So how do you do that? When you're constructing the true north, you must ensure that the true north that you're constructing there, these should be parallel to the other true north that you're going to construct there. So how do you ensure that you do that? By simply, you can transfer this angle. That is one way. You know how to construct lines that are parallel. You can transfer this angle. So if this angle here, if I'm to draw, for example, this is just an explanation. So if I'm to draw the true north there, you know that this is if this line is parallel to, let me just explain it here. So this one, north, north. So this is what I mean, that this line should be parallel to this. You must ensure that. That is very important. This line should be parallel to that. How do you ensure when you're drawing the true north it should be parallel? By just looking at this angle. You see this angle, 60, it should be corresponding to this. So you can transfer this angle here. So you must ensure that this angle that is here, this is 60, and then make sure you extend that line, and then this angle here should be 0.60. Reason being that these are parallel lines, and then these acts as a transversal. So this angle that is 60 here, it should correspond to this angle that is here. So when you transfer this angle, when you ensure that this angle is 60 degrees, and this one is 60, then automatically this line will be parallel to this, and I have to indicate this, that this should be parallel to that. So read mine is correctly drawn. I can just confirm that this is actually 60. As you can see, it is 60 degrees. You can see there is 60. Then now I should have an angle of 300. So an angle of 300, if I'm to draw a horizontal line here, and you need to be very keen when you're drawing that line as well. Let me use a ruler to draw that. I can use a ruler. So this is what you're supposed to do. 300 means that you're going to construct from the north in a clockwise direction. So from here you measure 300, so you'll be left with the 60 on this side. So you are supposed to make sure that this from here, this is 90, this is 180, this is a 270. So what is remaining from 270 to make 300? Just 30. You just need to add 30. So from this point, that is 90, this is 180, 270. So 270 add 30. So just need to measure 30 degrees on this side. Just need to measure 30 degrees on this side. Actually, let me place it like this. Actually, need to place it like this. So 30. So from this point here, so 30, that is there. So you can see that now I have this is 180, 270, then 30, and this is 30 in order to make 300. So the whole angle that I've measured is good to indicate this. So I've measured from this all the way to that point, that is 300 degrees. So I've just added 30 there. So that is the bearing. So B is on a bearing of 300 from R, and you're not given the distance. There's no distance that is given there. So I've just drawn the straight line there. So I think that is all. The positions, I don't see whether there's anything else. So B is on a bearing of 300 from R. So there's no distance that is given there. So I have to confirm show by construction the relative positions. So B is on a bearing of okay, there's something I did not do here. So R is on a bearing of 060. This is the first statement there. We did not capture the first statement, that B is on a bearing of 030 from W. B is on a bearing. That one you can just add that. I don't know how I jumped these. I jumped the first statement here. B, I continued from the second statement here. R is on a bearing of 060 degrees from W. I don't know why I started with that. All the same, there's no harm. We can still fix that. B is on a bearing of 030 from W. So from W, bearing of 030. So you just need to measure 30 degrees in order to get the position. So 30. So just measure 30 degrees. It will be actually be half over 60. Yeah, 30 degrees. That means it will be there it is, 30 degrees from W. So 030 will now be this angle that is here, 030. So B is on a bearing of 030 from W. So there it is. We've indicated that. And then B, the same B, is on a bearing of 300 degrees from R. So B will be located on this point here. this will be the point where B is. So you can see B from this statement, B is on a bearing of 0.30 from W. We've given that, so it is this particular line here. And then the same B is on a bearing of 300 from R. 300 from R is here. 300 from R, there it is. So B is located the point of intersection of this line. So this is exactly where we should have B. Now, having indicated all these positions, so we have indicated everything. Now everything is okay. We can proceed to the questions. Find the distance between banana and Wangige. Banana and Wangige. So that is a BW. The distance BW. BW. That is the distance we need to get. So let me take the measurement of that distance. So BW. So BW. So there it is. So I can see that this one is 6.7 centimeters. 6.7 centimeters. Yours might be slightly, you might notice a slight difference from my workings, just a slight, because of the digital tools that I'm using. So this is a 6.7 centimeters. 6.7 centimeters. Then you have to convert that. You have to convert that. So 6.7 centimeters, convert that, because you've given that 1 centimeter represents 0.8 kilometers. Don't forget that. So what about 6.7 centimeters? You simply need to multiply that by 0.8, and this will give 5.36 kilometers. Then how far east of Wangige is Ruaka? How far east of Wangige is Ruaka? So how far east? So that is a due east. In simple terms, you're being required to give the direction from W to R, and you're going to consider the direction that is directly to the east. So for you to do that, you have to simply extend this line here, extend that line like that, and then the other one that is here, you have to extend this one, this true north that is here, you have to extend that. So the distance that you need, because you need to give how far east of Wangige is Ruaka. So you can see that Ruaka is here, then Wangige is here. So how far east? It is this. Actually, this is the distance. This is the distance that you need from W to this point, due east. So from W to this particular point. So you need to get this distance here. That is why I had to drop these from Ruaka, drop that one directly down, due south, and then from W, due east. So this is the distance that you need to get. So let me take that distance in centimeter, then I convert that to kilometers. So you can see that is the distance is 6.6. That is giving approximately 6.6. So 6.6 centimeters, and then convert that to kilometers by multiplying by the scale given, 0.8. So 6.6 times 0.8, that gives 5.28 kilometers, and that is simply how you're supposed to solve that question. Question 20. A line L1 passes through points P, -1, 2, and Q, 4, 7. Part A of the question, write the equation of the line through P and Q in the form y is equals to mx plus c. So I have line 1, and for this line, it passes through 2 points, so 2 given points are there. So you're supposed to simply write the equation of the line passing through these 2 points. Now, when you're given 2 points and you're required to get the equation of the line, the first thing is to obtain the gradient denoted by m, and you know how we get the gradient. That one is given by the change in the y coordinates divided by the change in the x coordinate, and this one will be given by change in the y coordinate. We shall take 7 subtract 2, and then change in the x coordinate 4 subtract -1, 4 subtract -1, like that. So this one gives 5 divided by 5, and this one gives the gradient to be 1. So the moment you get the gradient, now the next thing is to take one of the points. You can take either P or Q. I will choose 4, 7. Let me choose 4, 7. 4, 7 is okay. So 4, 7, and then introduce another general point on the same line, and that general point to be xy, and you know the gradient will be 1. The gradient of this line passing through 4, 7 and xy will be 1. So let's calculate the gradient using these 2 points. A change in y, that is y subtract 7 divided by the change in x subtract 4. That should give the gradient, which is 1. So from there, you can cross multiply. Y subtract 7 multiplied by 1 is y subtract 7 is equals to x subtract 4 multiplied by 1, that would be x subtract 4. So because you want the equation in this form, what you do, you simply take this -7 to the right hand side, so that you have y is equals to x -4 plus 7, -4 plus 7, that would be +3, and that is the equation in the form y is equals to mx plus c. We go to part B. The line L1 intersects the x-axis at R. Determine the coordinates of R. So that line 1, I can just draw a simple sketch here to try to explain this. So this is the y-axis, and then this is the x-axis. So we have that line, and the line, let's say that is the line, that is L1. It cuts the x-axis or intersects with the x-axis at point R. So determine the coordinates of R. One thing that we can be sure of is simply the y coordinate of this point R. So you may not know the x coordinate, but we know the y coordinate is 0, because you can see this point R lies on the x-axis, and on the x-axis, all the points that lie on the x-axis, the y coordinate is equivalent to 0. So now that we have the y coordinate to be 0 and we don't have the x coordinate, we can get that one by simply getting the equation of this line, which is y is equals to x plus 3, and then we find the point where that line intersects the x-axis. So in simple terms, you're required to get the x-intercept of that line. And you know that at x-intercept, that is where this line 1 cuts or intersects with the x-axis, y coordinate is 0. So if I want to get the x coordinate of this point, I will simply take this equation, which is y is equals to x plus 3, and then at the point where it intersects with the x-axis, y is equivalent to 0. So take that equation and simply substitute y with 0. So y is equals to x plus 3. So that will be y is 0 is equals to x plus 3. So this will give us the x-intercept, the point where the line cuts the x-axis, and it cuts the x-axis at x is equals to negative 3 from this. So this x-coordinate therefore will be x-coordinate of that point r will be negative 3, and then we say that the x-intercept y is 0. So those are the coordinates. The coordinates of r is therefore negative 3, 0. We go to the next one, part C. Another line L2 is perpendicular to L1 and passes through R. Write the equation of L2 in the form ax plus by is equals to c. So I have another line L2 and it is perpendicular to L1. So from there, we know that when two lines are perpendicular, two straight lines are perpendicular to one another, then if we take the products of their respective gradients, it should give negative 1. So you already have, let me take the gradient of L1 to be M1, then the gradient of L2 to be M2, like that. So the gradient of L1, which is M1, we got that one as 1. Then the gradient of L2 is M2, that should give negative 1. So we can get the gradient of line 2 to be negative 1. So you already have the gradient of L2 to be negative 1. And it passes through R. So we have R, which is negative 3, 0. So if you want to get the equation, having the gradient at one point, you simply use that point which is given, which is negative 3, 0, and introduce another general point xy on that line. Then use these 2 points to calculate the gradient, of which you know the gradient is negative 1. So how do you get the gradient? Change in y. So y subtract 0 divided by the change in x. X subtract negative 3. X subtract negative 3, that will be x plus 3. And that gradient should be negative 1. So simply cross multiply here. Cross multiply. This y subtract 0, that is y. Y times 1, that is y, is equals to negative 1 multiplied by x, that will be negative x. Then negative 1 multiplied by positive 3, that will be negative 3, like that. So that is the equation of L2. Now we need to put that on in that form. Ax plus by is equals to c. The constant should be there. So bring the x and the y on the, so bring this on to the left hand side. So how do you do that? You simply add x. To eliminate negative x on the right hand side, you simply add x to both sides, so that you have x plus y is equals to negative 3. So if you compare these, ax plus by is equals to c, you can see it is in that form. So this is how you're supposed to leave it. X plus y is equals to negative 3. The last part, part D, S is a point on the line L2. Given that the equation of line QS is 6x minus y is equals to 17, find the coordinates of point S. So let me sketch this line. So we have L2. Let's say that this is the line L2, and then point, given that the equation of QS is that, so S is a point on L2. So let's say S is there, and then we have QS. We have QS. So this is Q. This is here. This is Q, and this is S. So you can see this is L2, line 2, and then point S is on that line, as you can see. And then given that the equation of QS, the equation of this is given there, which is 6x minus y is equal to 17. Find the coordinates of point S. So how do we get the coordinates of point S? You can see that point S is the point of intersection of these two lines, L2 and QS. So how do you get the point of intersection given two straight lines? by simply getting the equation of the two lines. So we have the equation of L2, it is up here. It is x plus y is equals to -3. And then we have the equation of Qs. So if we solve the two equations simultaneously, it will give us the value of x, the x coordinate, and the y coordinate of the point of intersection. So simply, to get this point of intersection, that is S, we need to take the equation of L2, which is x plus y is equals to -3. Then the equation of Qs, which is 6x minus y is equals to 17. And then solve the two equations simultaneously. It will give us the point of intersection there. So I can use elimination here. So y and minus y, how do I eliminate y? By simply adding. So I'll simply add the two. So x plus 6x, that is 7x. Y plus -y, that one is eliminated. Then -3 plus 17, that will give 14. So x is therefore 2. So let me substitute x in this equation. So x plus y is equals to -3. X is 2, so this will be 2 plus y is equals to -3. So y will be, this will be -3 subtract 2 to be -5. As simple as that. So therefore, we have the point of intersection S. The x coordinate will be 2, and then y will be -5. So that is the coordinate of point S. Then part E, the last one, find the angle between line QS and the x-axis to 1 decimal place. So the angle between QS and the x-axis. So I'll draw the Cartesian plane here. So that is the y-axis, then the x-axis. Then we have this line. Assume that is the line. This is the line QS, and we want to get the angle between the line QS and the x-axis. We want to get that angle. So how do we get that angle? We are going to use this concept here, that the gradient QS makes with the x-axis, the gradient QS makes with the x-axis is equivalent to the tangent of that angle. So the tangent of this angle that QS makes with the x-axis is equivalent to the gradient of QS. That is a very important concept. So we need to get the gradient of QS, of which we have the gradient of QS. We have the equation. The equation of Qs is 6x minus y is equals to 17. So we want to get the gradient, write that equation in the form y is equals to mx plus c. So it will be y is equals to 6x subtract 17. And therefore the gradient of Qs is 6. The gradient is 6. So we say that tangent of the angle the line QS makes with the x-axis is equivalent to the gradient of that line, that is QS, which is 6. So with this, we can be able to get the angle. So the angle will be given by the tan inverse of 6. And this gives the tan inverse of 6. That will give, correct 1 decimal place, 80.5. So this will give 80.5 degrees, and that is how you're supposed to solve that question. Question 21. These are questions on statistics. The frequency distribution table shows the masses in kilograms of 30 sheep in a livestock market. So there's a mass is given there. We have a mass in kg, the frequency, the mid mark. Then we have, or we can call this the midpoint, can be the mid mark or the midpoint. And then you have fx is given there. So The first question, you're supposed to find K. Where is K? K is here. These are missing frequency here. So how do we get K? You can see this one is in the column where we have the frequency. Frequency is the number of sheep, and they are 30. So that means if I add the total frequency here, the summation of the frequency, I should get 30. So by knowing that, I just need to add all these. So we have 4 plus 6 plus 8 plus K plus 3 plus 2. That should give 30. So this is 10, 18. This is 21, 23. So this will be 23 plus K should give 30. And here you'll be able to get the value of K. So K will be 30 subtract 23 to be 7. So that is 7. The value of K is 7. Part B, state the mode of frequency. So which is the mode of frequency? The mode of frequency is simply the highest frequency. Where do we have the highest number of sheep? Of all these, you can see 4, 6, 8. So 8 is the highest frequency. That is the mode of frequency. It is 8. Part C, estimate the mean mass. The mean mass. So how do we get the mean? Look at this data. These are column that has been created there, fx. So that means when you add everything there, you get the summation of fx. So you need to fill that column. So mean is given by the summation of fx divided by the summation of f for this particular data here. So you need to get this column, fill this column and get the sum. So we don't have the midpoint. The midpoint of these classes, the mid mass. So this should be the mid mass, not the mark, or the midpoint of the classes here. So these the mid mass will be given by simply take 60 plus 64. So 60 plus 64, and then you divide by 2. It is the mid mass, and this will be 62. So for the next one, 65 plus 69 divided by 2, that will be 67. The next will be 72. The next one will be 77. And the next one will be 82. The next will be 87. So how we get the mid mass. Then fx. You can see the first one will be 4 multiplied by 62. That will be 248. Then the next is a 6 multiplied by 67. That should give 402. 8 multiplied by 72. 8 multiplied by 72. That should give 576. Then the next is 77 multiplied by 7. 539. Then 3 multiplied by 82. 246. And then 87 multiplied by 2. That should give 174. So we get the sum, add everything. So you have 248 plus 402 plus 576 plus 539 plus 246 plus 174. That gives 2185. 2185. Now we have everything that we need to get the mean. So summation of f is 2185 divided by the summation of f, which is 30. So we divide these. So divide by 30. That gives 72.83 kilogram. That is the mean mass. The last one, estimate the median mass. The median mass. So how do you get the median mass of these type of data? It will be given by this formula. Median mass will be given by L plus N divided by 2, subtract CF divided by F, multiply by I, where the L is the lower class boundary of the median class, and then N is the total frequency, and then CF is the cumulative frequency above the median class, and then F is the frequency of the median class, and then I is the class size. So the first thing is getting the median class. So how do you get the median class? So the median class, we get the position by taking N divided by 2. N is the total frequency. Total number of sheep is 30 divided by 2. So the median will be given by the 15th sheep. So for that, we need to create a column here, the cumulative frequency column, in order to identify the median class. This is how you get the cumulative frequency. So from the frequency, the first one is 4. So add 4 plus the next one, which is 4 plus 6, it will be 10. 10 plus 8 will be 18. 18 plus 7, that will be 25. 25 plus 3, you get 28. 28 plus 2, you get 30. That is the cumulative frequency. So where do we have the 15th sheep? In which class? Look at the cumulative frequency column. So the 15th sheep is here. This is where we have. So the previous class, we have up to the 10th sheep. So from the 11th sheep to the 18th sheep, that is found in this class. So the median class is therefore 72, 74. That is where the 15th sheep lies. So 70 to 74. 70 to 74. Now having that, we will be able now to get L. L is the lower class. So now to get the median, we have L, which is the lower class boundary of the median class. The lower class boundary is 70 subtract 0.5 to be 69.5. The upper class 74.5. So the lower class boundary will be 69.5. Then plus n over 2. N is the total frequency, which is 30. So 30 divided by 2, that you get 15. Then subtract the cumulative frequency, CF, above the median class. So the median class, the cumulative frequency of the median class is 18. So the cumulative frequency above that class is 10. It is 10. So subtract 10. Then divided by F, that is the frequency of the median class. The frequency of the median class, which is 8. That class, 70 to 74. The frequency of that class is 8. Everything multiplied by the class size. How do you get the class size? To get the class size, just take, I can see all these classes are uniform. They are of uniform class width, or the class sizes. So just use one of the classes like this one, 70 to 74. You want to get the class size or the class width. You simply take the upper class boundary, which is 74.5, subtract the lower class boundary, which is 69.5. And that gives 5. So multiply by 5. So these will be 69.5 plus This is 5. 15 subtract this 5 over 8 multiply by 5, which will be 69.5 plus. This will be 25 divided by 5 divided by 8, 3.125. And when you add these, you'll get 72.63 kg. So that is simply how you're supposed to solve that question. Question 22. Question 22 is about transformation. Quadrilateral ABCD, whose coordinates are A 1 negative 1, B 3 0, C 3 2, D 1 3, and the quadrilateral A prime, B prime, C prime, D prime, whose coordinates are A prime negative 4 4, B prime negative 3 6, C prime negative 1 6, and D prime 0 4 are shown on the grid. So you can see them there. Part A of the question, given that ABCD is mapped onto A prime, B prime, C prime, D prime by a reflection, draw the mirror line. Draw the mirror line. For you to draw the mirror line, you need to understand one important property of reflection. And the property is the object point and the image point are supposed to be equidistant from the mirror line. In simple terms, the mirror line is supposed to be exactly at the middle of the object point and the image point, or at the center. So what you need to do, when you look at this image here, this is the image, this is the object. So you can join any object point and corresponding image point like C and C prime using a straight line. And then because the mirror line is supposed to be exactly between those 2 points, you draw a perpendicular bisector of that line. Also, you can join any other point B to its image point B prime. Then you join that using a straight line, and then you construct a perpendicular bisector, simply because in a reflection, the mirror line is supposed to be exactly at the middle of the object and the image. So I'll just choose one. I'll choose these. I'll choose D and D prime, D and D prime. So I'll simply join that using a straight line. So let me do that. I simply join that using a straight line. So we have D and D prime like that. And then the mirror line is supposed to be exactly at the middle of that line, D, D prime. You can choose any other point, A prime. I'm choosing this one because this is the easiest. Then when you draw a line that passes through, you can do this by actual construction. I noticed the moment I draw it like this, it will still serve the purpose when I draw it like that. So that should be the mirror line. You can construct a perpendicular bisector of D prime, but in this case I don't see the need, because once I draw that straight line using a ruler that passes through those corner points of the squares there, these you can see where the line is passing, these points, it passes through the center of D prime D. So that is the mirror line. And as I've said, you can use any other point. You can join B to B prime and then construct perpendicular bisector. You can use A and A prime, whichever point that you choose. So that is the mirror line. That is one mark. Then write the equation of the mirror line. So write the equation of this line. So how do you get the equation of a straight line? you simply need to identify any 2 points on that line, any 2 points. I will choose which point, negative 3, 0. I can choose that, negative 3, 0. So negative 3, 0. And then another point is 0, 3. Any 2 points that lie on that line. So I've taken these. This is 0, 3 and negative 3, 0. So to get the equation, you need to get the gradient first. So let me use the 2 points to calculate the gradient. So the gradient is a change in y, that is 3, subtract 0, divided by the change in x coordinate, which is 0, subtract negative 3. 0, subtract negative 3. And this will give 3 divided by 3, which is 1. So the gradient is 1. Now having the gradient, simply choose one of the points. I will choose 0, 3. And another general point on the straight line, which is xy. Use these 2 points to calculate the gradient, which you know is 1. So change in y, which is y subtract 3, divided by change in x subtract 0, is equals to 1. So when you cross multiply, you get this will be y subtract 3, multiplied by 1, then x minus 0, that is equals to x. So y is equals to x plus 3. So that is the equation of the mirror line. Simply get to any 2 points that lie on that mirror line, then get the gradient, then find the equation. Part B, A prime, B prime, C prime, D prime is mapped onto A2, B2, C2, D2 by a positive quarter turn about the origin. This is a positive quarter turn about the origin. So that one should be positive quarter turn is represented by positive 90 degrees. And you should know that this is anti-clockwise, positive quarter turn. That is the direction of that rotation is anti-clockwise, positive quarter turn. Now you're supposed to draw the quadrilateral A2, B2, C2, D2. So which is the object here? A prime, B prime, C prime, D prime. This is the object, and you're supposed to rotate this one through positive 90 about the origin. The center of rotation is the origin. Now I'll show you the easiest way to go about this by coming up with a simple formula. So for positive quarter turn about the origin, and you should know that in this kind of rotation, it is supposed to work in anti-clockwise direction. Just a good summary that will help you without having to measure the angle. For positive quarter turn about the origin, if you're given a point, let's say AB, given a point AB, and it undergoes rotation about the origin positive 90 degrees, and the center is the origin, this is what happens to that coordinate. You actually swap the coordinates. You swap the coordinates. When you swap these or interchange them, AB will be BA. BA, like that. And then you negate the new x coordinate. The new x coordinate is B, so you negate that. So it will be negative BA. So for any rotation given an angle of 90 degrees, positive 90 degrees about the origin, a point AB is mapped onto negative BA. Negative BA. That is for positive 90 about the origin. What about for negative 90? Negative 90, because you can also find these. For negative 90, you should know the direction of rotation here is a clockwise direction when you're measuring the angle. So given a point, let's say AB, and that point is undergoes a negative quarter turn, which is negative 90, both the origin, the center of rotation is that. So again, this one, you again interchange the coordinates, B, A, you interchange the coordinates like that. But now, this time round, you're going to negate the new y coordinate. So it will be B minus A. B minus A. You negate the new y coordinate. So this one is really going to help you once you have this understanding. And it is good to notice that positive, this is a positive quarter turn, that is positive 90, and then this one is negative quarter turn. So once you know these, you don't need to construct, you can simply just identify the coordinates and you'll be able to do the necessary. So for example, let me obtain I start with the first one, A prime. A prime is negative 4, 4. Negative 4, 4. So what will be the image of that? If we go by this is positive quarter turn, so minus BA. So of course you first interchange the coordinates and then you negate the new x coordinate. Okay, so this will be minus 4, 4, like that. So what about B? B prime. B prime is negative 3, 6. Negative 3, 6. So that one, this is what you get. You get negative 6, negative 3. So look at what is happening to the coordinates. So AB becomes minus BA. So you first interchange the coordinates and then you negate the new x coordinate. So for C, for C prime, you have, this is a negative 1, 6. Negative 1, 6. So C double prime will be negative 6, negative 1. And then for D prime is 0, 4. So D double prime will be negative 4, 0. Like that. So I can plot them. Yeah, let me plot them. So A double prime, negative 4, 4. No, negative 4, negative 4. I think I made a slight error here. This is negative 4, negative 4, because you're supposed to interchange the coordinates and then you negate the new x coordinate. So when you interchange, you get 4, negative 4, and then you negate the new x coordinate. So that will be negative 4, negative 4. So negative 4, negative 4 will be here. So that is A double prime. And then B double prime will be negative 6, negative 3, negative 6, negative 6, negative 6, negative 3 is 0. B double prime. And then C double prime, negative 6, negative 1, negative 6, negative 1. So that is where C double prime is. And then D double prime will be negative 4, 0. Negative 4, 0 is 0. Negative 4, 0. So there we have the points. So I can join them now. I can join them, A to B, and then B to C, and then to D, like that, and then there it is. Now alternatively, if you don't know these, you can decide to join. For example, just demonstrate using the first one here. Suppose you don't have any idea about this concept here. Now what you can do, because you are actually rotating through positive 90 about the origin, you take, for example, A prime, that is the object you want to rotate, You join it using a straight line to the center, like that. Join it to the center of rotation, which is the origin. And then you know that you're supposed to measure positive 90 degrees in anti-clockwise direction. So from here, you will have to use a protractor. Let me just bring it here, and you'll notice that is exactly what you will be able to have. So this is how you place your, make sure you place it like this. Yeah, sorry. So you can see how I'm placing. So after joining A prime to the origin, yeah, so join A prime, the origin, you want to get the image, and then the angle is supposed to be measured in anti-clockwise. So you're supposed to measure the angle from this going this way. This is the direction from this point going this way. So that you'll notice that 90 degrees will be there. You can see that is exactly where I have my point. You can see. So 90 degrees, you've measured 90 degrees this way. So from these how you've measured 90 degrees in anti-clockwise direction, that is positive 90 degrees. And then you take this distance. Once you draw this line, straight line, you take this distance from A prime to the origin, the center of rotation. Take that distance and then transfer that distance. You stand at this point, the center of origin, and then mark with that distance, mark the point where you shall have A double prime. So you notice that this distance is supposed to be the same. A prime O should be the same, that distance should be the same with this one, from O to A double prime. You just count. You can count the number of squares actually. That is the easiest way. So how many squares are here from the origin to A prime? Those are 1, 2, 3, 4. So you measure from here again. From here you have 1, 2, 3, 4. So you have the point there. So that is the other way you can go about that, just in case you find you don't remember, maybe you want to do it through construction, you can get the image in that way. So we have drawn the image. Now state the coordinates. State the coordinates of A double prime. We have the coordinates here. I've already stated them. They are here. All the coordinates are here. I don't need to repeat them here. So we have drawn the quadrilateral. It is here. And then the coordinates are here. The coordinates are supposed to be written in this form. Then part C. A double prime, B double prime, C double prime, D double prime is mapped onto A3, B3, C3, D3 by an enlargement scale factor 2. Scale factor 2. Center, -1, -3. Draw the image. So this is an enlargement, scale factor 2. Center is -1, -3. First we identify the center, -1, -3. So -1, -3 is here. This is the center. So let me mark the center here. So -1, -3. So there is the center. So there is the center. So we are supposed to, the object here is A, the one that we have already drawn here. So this is the one that you're supposed to enlarge through this being the center. Now, because this one is positive, is an enlargement by a positive scale factor. For an enlargement with positive scale factor, you're supposed to note that the object and the image should be on the same side with the center of enlargement. But for enlargement that has negative scale factor, the object and the image are on the opposite sides with the center of enlargement. So that means because this one is an enlargement with positive scale factor, so it means that the object and the image are supposed to be on the same side with the center of enlargement. So the image cannot be here, because if it is here, you can see the object and the image will be on the opposite sides, and that one happens in case we have a negative scale factor. Now, because this one is a positive scale factor, then the object and the image are supposed to be on the same side. So this is what we do. Using a ruler and a straight line, you are supposed to join each of these points from the center. So from the center, join using a straight line to A, using a straight line, join that one to A like that. So from the center to each of the objects, then from the center again, center of enlargement to B using a straight line like that. Then from the center again to all the points to C, C is there. Yeah, it's supposed to be there. Then from the center again to D, like that. So you join all the object points. So from the center to A, double prime from the center to B, from the center of enlargement to C, from the center to D. So once you do that, you're supposed now to enlarge by scale factor 2. Scale factor 2. So scale factor 2 means you're going actually to double the distance. So look at the distance. You start with A double prime. What will be the image? So from the center of enlargement to where the object is, how many squares are these? These are 1, 2, 3. So that means if we are enlarging this one by 2, we double that distance. So there are 3 squares. So from here we are going to count double of that, 6. So 1, 2, 3, 4, 5, 6. So it's supposed to be here. A triple prime is supposed to be here. So this is where A triple prime is supposed to be there. So again, we go to B, we count. So from B to where, from the center of enlargement where B double prime is, how many squares are those? 1, 2, 3, 4, 5. So double that distance, that will be 10. 5 times 2. So from here you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is why we should have B triple prime. B triple prime. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we go to C. At C we have 1. So we want to take this distance. 1, 2, 3, 4, 5. So again, we are going to count 10. So from here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We actually doubling that distance. You double that distance. So 10 will be here. So this is where we shall have C triple prime. You can actually take that distance using a pair of compass as well. So we're taking this distance, then you double it. So you count like from this point to this point. We've noted there are 5 squares. So when you double that, you count 10 squares from here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we go to D. So from D double prime to the center, how many squares are those? Is 1, 2, 3. So doubling that distance, we're going to count 6. So this is a 1, 2, 3, 4, 5, 6. So that is where we should have D prime. So now we have all the points, so we can join them. So we can join them using straight lines. So from A to B, then from B to C, then from C to D, and then from D to A. So that is the image. So you can see now, this is the object after being enlarged, the center being there, center of enlargement is there. This is the image. So we've drawn. So the only thing you're supposed to do there is to draw the image, and make sure after you draw every image, you label all the vertices. And that is how you're supposed to solve that question. Question 23, part A. The figure below shows a milk packet in the shape of a regular tetrahedron VABC of sides 12 centimeters. Its vertical height is 9.6 centimeters. Calculate the volume of the milk contained in one packet. So the packet is there. So you're required to get the volume of the milk that is contained in that packet. And therefore, you simply need to get the volume of that packet. Now, when you look at this packet, it has a base that is an equilateral triangle. It has a uniform length of 12, 12, and 12. So this is an equilateral triangle. So how do you get the volume of this tetrahedron shape? You need to use the formula. Volume is equivalent to a third base area times the height. That is how you're going to get the volume of this tetrahedron shape. So when I look at the base, we can get the area of the base. This one is an equilateral triangle of sides 12. So you can use the Hero's formula, and you can also use the formula have AB sin theta, because in an equilateral triangle, you know that all these angles are equal. All these angles are 60 degrees. So all those angles are 60 degrees, and therefore we can use this formula. Area is equals to a half times AB sine of theta. When you have any two given sides and an included angle, there's an angle between the two given sides, you can use this formula. So therefore, volume is equals to a third times the base area, which is the area of the triangular base, will be given by a half times AB, any two given sides, 12 times 12, times the sine of an included angle, which is 60. So that is the base, and then we multiply by the height. The height is 9.6. So that is what you're supposed to work out. So use a calculator to work out that. Use a calculator to work out that. So a third times a half times 12 times 12 times sine of 60 times 9.6. That one should give 189.5. 189.5 centimeters cubed. We go to part B. The figure below shows a bucket in the shape of a frustum of a cone. The top radius of the bucket is 21 centimeters and the bottom radius is 10.5 centimeters. Its vertical height is 0.5 meters. You need to be very keen with the units of the measurements. You can see this is centimeters, these centimeters, then the height is the only one that is given in meters. So we can begin by changing that so that you can have uniform lengths. So we can simply convert 0.5 meters to centimeters by simply multiplying this one by 100, and this one will give 50 centimeters. So that is 50 centimeters. That is so that you can have uniform units. Now you're supposed to calculate the volume of the bucket. So the bucket is in the shape of a frustum of a cone. So how do you get the volume of this bucket? So the volume, as you see, there's no particular formula that we can use to get directly the volume of this bucket in that shape of frustum. So we have to complete and use the cone, because this bucket was obtained from the cone. It was obtained from the cone. So this is how the cone was. The cone was like this. So this is where the bucket was obtained. So originally it was like that, and then it was cut off. When this part was cut off, that is why you remained with this. So in order to get the volume of the bucket, so the volume of the bucket, and that bucket is the first term, this will be given by the volume of the big cone, then subtract the volume of the small cone. So you can see we have two cones. The bigger one, the one that begins from this point, so the bigger one, the whole of this, and then the smaller one, that is the beginning from this. The smaller one has a radius of 10.5, then the bigger one has a radius of 21. So how do you get the volume of a cone? Volume of a cone, volume is given by a third pi r squared, that is the base, the circle, pi r squared, multiplied by the height. So what we have the radius of the bigger cone and the radius of the smaller cone. So what is missing is the height of both the bigger cone and the smaller one. So the height of the bigger cone, the one that runs from this point, so that is the height of the bigger one. The height of the bigger one runs from that point to that point, and since we have the distance up to this point, this one is 50 centimeters, we can let this one to be x centimeters. So we have 50 centimeters, that is the height of the first term. So for us to get the height, then the height, let me this one, this will now be this one that I refer to as x. So this is x. So to get the height of the smaller cone and the height of the bigger cone, we need to find the value of x, and for that one you're going to use similarity. We have two similar figures here. We have two cones, the bigger cone and the smaller cone. So we can use similarity, the ratio of the corresponding side, that is the linear scale factor. So the height, we can use the radius of the bigger cone divided by the radius of the smaller cone. That should give the height of the bigger cone divided by the height of the smaller cone. That is a similarity. The ratio of the corresponding sides is supposed to be constant. So the radius of the bigger cone is 21, then the radius of the smaller one is 10.5, and then the height of the bigger cone is 50 plus x, and then the height of the smaller cone is x. So you can see with this equation, it is possible now to calculate the value of x. 21 times x, this is 21x, is equals to 10.5, 50 plus x. So this will give 21x is equals to 10.5 times 50. That gives 525 plus 10.5x. So here you get 10.5x is equals to 525. So x will be 50 when you divide both sides by 525 divided by 10.5. So this is 50. So therefore the height of the bigger cone, will be 50 plus 50, that is 100, and then the smaller one will be 50. So with that, now it is possible to calculate the volume. So we can calculate the volume of the bucket. So the volume of the bucket will be given by the volume of the big cone, which is a third times pi, 22/7, times the radius squared, which is 21 squared, times the height, which is 100. That is the volume of the big cone. Then subtract the volume of the small cone, a third pi r squared, 22/7, times the radius squared, which is 10.5 squared, times the height, which is 50. So when you work out these, third times 22/7, third times 22/7, times 21 square times 100, that gives 46,200. 46,200 centimeters cubed. And then a third times 22/7 times 10.5 squared times 50, that gives 5775 centimeters cubed. So when you subtract, now you get the volume of the bucket, and this will give 4425 centimeters cubed. So that is the volume of the bucket. We go to part 2. The number of full milk packets from part A above obtained from the full bucket. So from the volume that we've just obtained here, 40,425 centimeters cubed, how many packets can come from that? The volume of one packet we had in part A was 199. So one packet has a volume of 199.5 centimeters cubed. So, and the bucket has a volume of 40,425. So to get the number of full packets, you simply take the volume of the buckets, the volume of the bucket, that is 40,425 centimeters cubed. Then you divide by the volume of one packet in part A, which is 199.5 centimeters. So these will give the number of packets that can be obtained from the volume of the bucket. So when you divide these, you will get 202.6. So the one that will be full, so you'll get me right here, 40,425 divided by 199.5. So you get 202.63 buckets. So because we need the full buckets will be given by 202. The fraction part here means that there's a bucket that will not be full. So 202 buckets are the ones that we need. That is how you're supposed to solve that. Go to question 24. Question 24 is on velocity time graph. The following is a velocity time graph for a particle in motion. So you can see it there. Use the graph to calculate the acceleration during the first 4 seconds. So how do you get acceleration? Acceleration is obtained by getting the final velocity minus the initial velocity divided by the time taken. So in this case, we want the first 4 seconds. So look at the scale in the x-axis. You can see 1 centimeter here represents 5. So 1 small square here is 4, or is 1. So you have 1, 2, 3, 4. So 4 seconds. We need it up to this point. So we need it up to that point. So that is why we have 4 seconds. 4 seconds is there. So we need to get the final velocity. The final velocity is 40, as you can see here. So from 4 seconds, 40 meters per second. So 40 meters per second. Then the initial, of course, it is started from 0. The initial is 0 meters per second. And then the time taken is from 0 to 4 seconds. So that is 4 seconds. So this gives 40 meters per second divided by 4. Divided by 4 seconds. So this will give 10 meters per second squared. So that is how you're supposed to do that. Then you go to part B, the deceleration of the particle, the deceleration. So when you look at the graph, which area does deceleration occurs? Acceleration is where we have an increase in speed, a positive increase, and then this particular part where the speed is decreasing. You can see from this point the graph is moving downwards. So this is the point where we have deceleration. So this is the point. So along these lines, so this is where deceleration or retardation is happening. So you need to get the deceleration, so from this point to this point. So the same way, we shall do that by getting the final velocity, which is 0 meters per second, because that is it is decelerating from this point to this point. So this is the final velocity, which is 0 meters per second. Then the initial, it started from here, the initial is 90. So 90 minus 90 meters per second. And then the time taken where this deceleration is happening is between this point 25 seconds to 30 seconds. That is 5 seconds. So that is subtract 25, that is 5 seconds. So this will give negative 90 meters per second divided by 5 seconds. And this will give negative 18 meters per second squared. Part C, the distance covered in the first 10 seconds. The distance covered in the first 10 seconds. The first 10 seconds. So the first 10 seconds means we need to get the distance up to this point. Up to this point. So you need to get the distance from 0 to 10 seconds. So how do you get the distance? To get the distance in velocity time graph, distance covered is given by the total area under the graph. So if we get the total area under this graph between 0 and 10 seconds, we get the total area under that. That will give us the total distance. So we therefore need to get the total area under that graph between 0 and 10 seconds. So to do this, we will simply get the area, identify this shape. So which shape is this? Because we need to get the total area under that graph between 0 and 10. This one is this is a trapezium. And to get the area of a trapezium, it will be area times a, this is a half, multiplied by the sum of the two parallel sides. So the two parallel sides is this one, this side, this is 10. So this is 0 to 10, and then this one is 5. So this will be 5, that distance will be 5, and then this one is 10. Okay, yeah, so this will be 10 plus 5. 10 plus 5, and then the height will be this one. This will be the height. The height will be 50. So the height will therefore be 50. So that is how we get the area. So this will give a half times 15 times 50. And this, when you work it out, 25 times 15, this will give 375 meters. Then the other part, the total distance traveled. So the total distance traveled now will be the total area under the whole graph. So from this point, from the initial point, this is 0, from 0 to 30. So what is the total area under that graph? So we say that in velocity time graph, the total distance is given by the total area under the graph. So we already have 375, so the remaining area is this one. So I can divide this area into sections. So I'll start by getting this area here. So I can get this one here. Let me mark it. So there's this shape that is here. So this one is another trapezium. So that is another trapezium. I will simply name this region as A, the whole of this region here. This will be region A, then this one will be region B. So you already have the area of A as 375 meters. So what about B? So for B, this is trapezium, so this distance here 10 to 15, this is 5, and then we have this one is 50, and then this one is 90. So the two parallel sides, so the area of B, a half times 50 plus 90, and then multiply by 5. 50 plus 90, so you can see where 50 is, this distance here, this is a trapezium, shape B is a trapezium. Then we have the other side, which is 90, then 5, so which will give, this will give a half times 140 times 5, so this will give 7 times 5, 350 meters. Then the other shape, I will take the whole of this shape here. So from this point, so this shape here, I'll take the whole of this as 1. So this is a rectangle. So this is a rectangle. I'll name this a C. So name that one as C. So this rectangle measures 90 by, so from 15 seconds to 25, that is 10. So this length here will be 10. So it's a rectangle measuring 90 by 10. So the area of C, 90 times 10, that will be 900 meters. And then the last one there, this is D, that is a triangle, 25 to 30, that length is 5, and then this is 90, this is 90. So that is a triangle, half times base times height, half times base times height. So for D, so you have half times the base is 5, the height is 90. So this one gives 45 times 5, 45 times 5, it gives 225 meters. So now the total distance, we shall add the area of A, which is 375, plus the area of B, which is 350, plus the area of C, which is 900, plus the area of D, which is 225. So you add these, so 375 plus 350 plus 900 plus 225, that gives 1850 meters. So that is the total distance, total area under the velocity time graph. The average speed, the whole journey, how do you get the average speed? It is given by the total distance divided by the total time taken. Total distance already we have, that is 1850 meters. Then the total time from 0 to 30 seconds. So that is 30 seconds. So you simply divide this 1850 divided by 30, and this gives 61.67 meters per second.